So here's number 39 from your textbook. We've got a 70 kilogram diver who steps off a 10-meter tall tower and drops from rest straight into the water. If he comes to rest 5 meters below the water, what's the average resistive force? I'm going to break this into two parts and figure out what his velocity is just before he enters the water first. And then once we have that, solve the other part. It turns out you could do it all in one step, but I sort of want to break this into two parts so you can sort of see it a little bit better. Arbitrarily, I'm going to define the height of the water as h equals 0. That means initial height is going to be 10 meters, and final height, interestingly enough, is actually negative 5 meters below the water surface. So the height is going to be negative 5. All right, solving this one. Initial energy plus work is equal to final energy. Our diver starts out with gravitational potential energy, mgh. There's no frictional force, no energy lost. And the final energy is all going to be kinetic, just as answer there. Because h equals 0, there is no gravitational potential energy at this final point. If we solve that, we'll get that they enter the water at 14.1 meters per second. This is actually not required to actually solve this problem, but I thought it was kind of interesting. So that's how fast he's moving. And now what's going to happen? Well, once he hits the water, his initial energy is kinetic and also actually no gravitational because at h equals 0. Final energy, though, interesting enough, he's stopped. This final velocity over here is 0, so no kinetic. But interestingly enough, it does have gravitational potential energy, negative gravitational potential energy, because the height is below 0. So what we end up with here is our final height is negative 5. The work done by this force, we'll assume it's acting at a constant force through that entire distance of 5 meters times the cosine of the angle. Remember, our diver was moving this way. The force is that way. The angle between the displacement and the force is 180 degrees. Solving it, we get that. Now, here's the one quick note I want to mention. Yes, we could have simply plugged in this 7,000 as the initial energy right here, and just set this up as the initial energy was mgh plus the work equals the final energy. I went and first solved the velocity and then used that here. You could have just used this 7,000 and brought it straight to here without a problem. In solving this one, then, you get the average resistive force is 2,100 newtons. Which is, a lot of force. And probably would hurt a lot, too. That is the net force acting on that person while they're going down. Yeah, it's a fairly large force. Good. Good luck with this one. Have a good night. We'll talk to you soon.